last one, if the numerator is exactly 1 degree greater than the denominator. If it's any more, there's not going to be any asymptotes. So if you had something like x to the third plus 4x plus 10 over x plus 6. If you have bigger than 1 degree difference, there's no vertical asymptotes. Excuse me, there's no horizontal or oblique because of this difference between 3 and this. So we've got, if the top's smaller, we have an asymptote. If they're the same, we have an asymptote. If it's 1 bigger, we're going to have an asymptote. But any more than that, there aren't going to be any. We would still have a vertical one. We'd still have a vertical one at -6. But that's just because the function's undefined. These other ones are talking about the function approaching some value. And when this is more than 1 degree greater, it's not really going to approach anything. It's just going to grow unbound. Because this is growing too fast for this to strain. An example of this. F of x. X squared minus 9 over x plus 1. So x squared minus 9 divided by x plus 1. Let's do our synthetic division here and try and simplify it. So I've got 1x squared, I've got 0x, and I've got -9. In my box would go what? -1. I bring down the 1. 1 times -1 is -1. Plus 0 is -1. -1 times -1 is +1. And -9 plus 1 is -8 for my remainder. And what that represents now is f of x equals 1x. Right? This was x to the second, so this is x to the first, minus 1, and then that remainder, minus 8 over x plus 1. These functions are the same. You just divide it to make it a different format. And what we see is that this part, as x gets really big, what happens to that quantity? Okay, divide by a really big number. It becomes silent. What happens when you divide by a really big number? That's right. And the bigger the number gets, your ratio becomes closer to what? 0. So this is the idea of an asymptote, is that as x gets really big, this part becomes non-existent or trivial, or it doesn't matter. Although this part continues to be important. So the reason we divide is to eliminate that remainder, to say on large values that doesn't matter, and f of x equals x minus 1, that straight line, x minus 1, right, that's slope and intercept form, right? -1 is the intercept, goes up 1 over 1. That line is what we would call an oblique or a slant asymptote. And so instead of the graph getting flatter and flatter, it would do something where it got closer and closer to that line as x gets big or small. So it might do that on one side, and it might go like this over here. It's slanted, but the graph is still going from a curve to approaching that flat line.